People of the internet, welcome to Modern Day Debate. Tonight we are debating the scientific evidence of a young Earth, and we are starting right now. I am Kaz, host of the Atheist Edge. Tonight we have Conspiracy Catz versus David McQueen and special guest moderator Standing for Truth. And at this moment, I'm going to kick it over to Standing for Truth to take over the moderation duties for the rest of the time being. Standing for Truth.
Awesome. Thank you, Kaz, for the introduction again tonight. Is there scientific evidence for a young Earth? And we are blessed with two true professionals in the debate world, Conspiracy Catz and David McQueen, both very knowledgeable and always make for a great exchange, which means this will be a debate to remember. So I'm excited. I know the audience is excited as well. But before we get into the opening statements and the debate itself, let's break the ice a little bit, get to know our guests a bit. Catz, why don't we start with you? Great to have you here on Modern Day Debate. I appreciate you being willing to engage in these important debates. So let's start with you. A little bit about yourself, how you been, and a little bit about your channel.
Well, first of all, good to catch up with you again. I know we sit on different sides of the fence, but we've debated a couple of times in the past, haven't we, Donnie? And
that's right.
And I always enjoyed those. You were super respectful, super nice. Debates went really well. So I'm, nothing against James. I like James, but I'm chuffed you're here. It's nice to chat with you again.
I appreciate that.
But my channel's not really worth shouting about at the minute. I did have a couple of quite large channels, but I gave them away because I got too busy really to make content for them. So I've got a little smaller channel, which I'm kind of taking a break from at the minute, again, just because of real world stuff. So there's nothing to shill out or shout out, but I can be found at Culture Catz. But there probably won't be much content coming out there for a while at the minute. And that's it, really. In my real life, I'm a teacher, science teacher for 20 years. And I tell this to everybody just because I like to. I've got some textbooks being published in the very near future, fingers crossed. So
very cool. Very cool, Catz. Congratulations on that. Yes, we've both had a couple. We've had a couple debates in the past. I've enjoyed those. You've always been professional, cordial, and we have that mutual love for superheroes. So, Catz, I always appreciate your time. David McQueen, good to have you as well, brother. How have you been? A little bit about yourself and a little bit about the work that you've been doing.
Well, thank you very much, Donnie, and also my thanks to Modern Day Debate. Al, as you were doing your introduction, where do you teach? What grade level do you teach?
Secondary. So over here, it's up to 18-year-olds.
Up to 18. Is it called second form or something?
No, so sixth form will be the
sixth form
over here. But I did from 11-year-olds to 18-year-olds.
Okay, the reason I wanted to hear that is that over the years I've been what on our side of the pond is called a high school teacher, and have taught high school science. I've taught at the university. From my experience with exchange students from Europe, oftentimes they operate as if they're in college whenever I teach them at what we call the high school level. But my background is as a professional geologist, my undergraduate from the University of Tennessee, my master's from the University of Michigan, and a long-time interest in this whole issue of scientific evidence for a young Earth. And so I'm very anxious to get started. Sometimes we have a moment of humor. Can we have a moment of humor, Donnie, before we get into it?
A moment of humor is allowed, David.
Okay. When my grandchildren come over, sometimes they complain about pterodactyls coming into our bathroom in the night. And they well, why can't you hear it, Grandpa? Well, the P is silent. Pterodactyl P. It's not the best.
That's good, Professor McQueen. Appreciate the humor. Now that the humor is out of the way, the showdown begins.
Okay, very well. Start our timer.
David, Catz, appreciate the introductions from the both of you. And for the audience sake, though, let me just go over the format real quick. So we are going to be having 12-minute opening statements. Again, the title for tonight is there scientific evidence of a young Earth? David would say yes, and so he's in the affirmative, which is why he will be kicking us off with his opening statement. Then we're going to have 8-minute uninterrupted rebuttals, followed by a 5-minute break, where Kaz and I will go over some announcements and reminders. And then we are going to get into a 40-minute back and forth discussion. So rather than a real strict cross exam, it's going to be more of a free-flowing discussion where the debaters can ask each other questions pertaining to the topic of tonight's debate. Then we'll have a 5-minute closing statement. And then this is where we get you guys in the audience involved. We're going to have a roughly 25-minute audience Q&A. And so please, if you have questions, make sure you're tagging Kaz. And so Kaz is going to be saving the questions for tonight. So David, we're going to hand it over to you. And whenever you're ready, you've got 12 minutes. The floor is yours.
Okay. Go ahead and give me a full screen, and I will begin my line of arguments. Even though I've come to believe in my study and work as a geologist over the years that there are actually hundreds of evidences for a young Earth. And be sure that you understand in the audience my viewpoint. I'm talking about thousands versus billions, thousands versus millions. The idea that the Earth is young has been a historical foundation for many centuries, up until the time of Darwin, up until the time of Hutton and others. And so I'm arguing a position that's been around for a while. But we have both 20th century and also 21st century data, which indicate that there are actually scientific reasons to believe that the Earth is young. 50 years ago this year, not 2023, but back in 1973, when I was an undergraduate student, I worked for R.V. Gentry at the famous Oak Ridge National Labs. I was a lab assistant for him, and the paper that I'm going to debate with Kaz as the night goes on, Al rather, is based on work I did with him, measurements I made, and also actually editing as best I could the paper that he did. And the argument that I want to put forth is that Gentry worked on what are called radioactive halos. Now, to get a sense of what a radioactive halo looks like, here is a book that Gentry wrote. And this is a polonium halo there in mica. And then here is a group of polonium halos in a layer of mica. Now, how can you, if you're unfamiliar with this argument, conceptualize this polonium halo or uranium halo? Let me help with some models. If you imagine this, and I'll turn my red dot there so you could see it. If we could go in that red dot all the way to the nucleus of a polonium atom, we would see radioactive decay from uranium. But as a geologist and as a mineralogist, what is that red dot when you get to the center? Well, perhaps this would help to illustrate it. Here is a hemisphere. Imagine that along this section here, you have a mineral called zircon, which is zirconium silicate, having room for uranium and thorium and so forth. What Gentry did is he hired me to sit at a microscope with thin sections and polish down those minerals until you got a true diameter. The importance of having a true diameter will come out more in the next hour and a half. But the summary for my beginning is this. The polonium halo illustrated here, as you can see behind me here, is a polonium halo with a half-life of less than 5 minutes. If this is found in granites, such as this model, which we'll talk more about, in the Earth's crust, then that has tremendous cosmological implications of a rapidly cooling magma. The second point of Gentry's work is the point that if you look at the diameters of these halos and you measure them very carefully from Precambrian all the way up through Paleozoic, Mesozoic, Cenozoic, the standard geologic vocabulary, the diameter of these halos do not remain constant. And we'll work through the calculus later on about how that shows that because the diameters are not constant, the decay rate is not constant. Okay, the second argument that I want to build is an argument based on population statistics. So we have a population of around 8 billion people. And so let's look at the algebra. And this is not, as they say, rocket science here, but this is algebra. And perhaps I can hold it a bit closer and make it more clear. From my viewpoint, the man and the woman, or Adam and Eve, or one of the descendants of Shem, Ham, and Japheth, talked about after the time of the flood. From the evolutionary viewpoint, these are individuals that have found themselves in sub-Saharan, sub-equatorial Africa, probably, and they begin to reproduce. Now, the basic population statistics involves two people, C to the N. So if we set that equation equal to the modern population of 8 billion, we can easily see that if we break it into 4,000-year units, you can have about 100 generations in 4,000 years. The actual equation is 2C equal, and then you can see the rest of there, 1 over 100. When you factor in the painful, wicked world that we live in and add in famine, war, and sickness, the young Earth estimate, this estimate of 100 generations in 4,000 years, gives an adequate number of generations to explain the 8 billion people. My challenge to Al is, even if you factor in famine and pestilence and death and earthquakes and volcanoes, the world population should be much, much bigger, orders of magnitude bigger. Okay, my third argument that you'll see here deals with the decay of the Earth's magnetic field. Even though this argument has been around post-World War II, in my research preparing for tonight, I found some data that extends it from 1835 all the way out into the 21st century, 2005. The intensity of the Earth's magnetic field is measured, if you remember your physics from school, as a magnetic moment. That's an amp per meter squared times 10 to the 22nd. And so historically, this number has ranged from 8.6 to 7.8. Now, that gives a half-life of the magnetic field of about 1,400 years. Now, if you multiply that number, that half-life, by 32, you get a very strong field about 7,000 years ago. Now, I am arguing that the modern dynamo theory of the generation of the magnetic field is incorrect, but rather that fluid currents flowing in the outer core, and this is the right-hand rule that you may have learned in physics, and I can illustrate it this way. If this is our model of the Earth, I'm arguing that there is evidence that there is a electric current in the mantle that is moving equatorially, and by the right-hand rule, so you wrap your fingers around the direction of the current, and the direction of your thumb is the magnetic direction. And so this is why we can have a North Pole and South Pole. How many minutes are remaining for me, please?
It looks like you have 2 minutes exactly.
Okay, good. The fourth point that I want to challenge Al on deals with the volume of metallic ores in our world. I want to focus not on my training of copper, lead, zinc, gold, silver, because I've worked as an economic geologist. I want to focus on nickel for a number of reasons that you'll see why this is true as the argument goes on. But the basic argument runs this way. If we look at the amount of nickel that is in rocks, such as that granite I showed you earlier, you can get what's called a crustal abundance of nickel. If you look at the erosion, and I'm using evolutionary timescale here, if you look at the erosion of nickel from the continents, even understanding that there are subducting plates, so I am a proponent of catastrophic plate tectonics. So no question there's been some subduction. But it's also the case that the evolutionary community views the Atlantic Ocean, since that's what separates Al and me tonight, as about Jurassic Age. If it's the case, there would be a tremendous amount of nickel that could have eroded, and depending on how you want to pick it, from 70 million years ago all the way back to 170 million years ago, far more nickel than we actually find in the oceanic sediments. And so with those four arguments, I would like to kick it off, and I'll now get my sheet of paper and record Al's arguments.
David McQueen, thank you very much for that 12-minute opening statement. We are now going to hand it over to Catz. Catz, you also have 12 minutes for an opening statement. If you need to share screen or anything like that, just let Kaz and myself know, and we can get that up for you.
Yeah, I will share screen. Thanks for that, David, by the way. Appreciate that. So let me just get... How do I do this?
As you're doing that, I'll remind the audience, if you do have questions, again, the topic, scientific evidence of a young Earth, just make sure you're tagging Kaz, but specifically at Modern Day Debate. And that way he won't miss your questions.
Al, I've got my pen and paper ready here.
Just wondering why I can't get my screen to show. I think I know why. Okay, let's do that. Sorry, guys.
No worries.
Technical thing on my part. Has it changed the screen sharing?
A little bit on the StreamYard. So it might say present now.
It's at the top, isn't it? It's at the
top. for me specifically, it's kind of right in the bottom, in the middle, right next to where it says, okay, we got it.
Yeah, should got it. Yeah, sorry, it was a little bit different than the last time I used it. Okay, so is it up? Am I?
It is. Yep, it's up on the screen.
Is it up? That's what she said.
Yep.
Now, so I'm really looking forward to this debate because normally I'll debate flat earthers or people who don't believe viruses exist, who are just coming to a debate to say, show me evidence the earth isn't flat or show me evidence viruses exist. And they will sit there and not understand a word that's been said to them. And at the end, just claim that no evidence has been shown, no matter how hard I try to show them that the earth isn't flat or viruses exist, etc. But when this debate was organized, I was really, really happy. You can see on screen there the email I got from James, and the title we agreed on is there good scientific evidence of a young Earth? And I thought that's fantastic because that puts me in the opposite position to what I usually am, where I can be presented with evidence for flat Earth and get evidence for a young Earth and get to decide for myself, do I feel that is valid evidence or do I feel that actually there's no substance to that evidence whatsoever? So for me to actually bring something in my opening statement, well, I don't think there is good scientific evidence for a young Earth, so I'm not going to bring evidence for that. So my opening statement perhaps will be a little bit different today. I want to point out just in my opening statement, until I get to my rebuttal stage, how I've found the young Earth creation argument in the past and some of the ways that they've misused science and some of the ways they've tried to find a way out of problems. So, for example, I think we all know the story in 1992 when Dr. Austin took that rock from Mount St. Helens. It was 10 years old, and he tried to trick a radiometric dating lab by taking it to the lab. And lo and behold, it came back as being 3 million years old. And he said, well, look at that. Look how flawed radiometric dating must be because we know this rock is only 10 years old. But of course, what he didn't say is that there's about a 3 million year kind of like window of error when you're doing this type of radiometric dating. And he didn't inform the lab at all that this was 10 years old. It was a very, very almost dishonest use of his time and the time for the people in the lab. And this is the kind of thing that young Earth creationism kind of gets known for, this kind of bad, kind of dishonest sort of science. But I do like the little catchphrases that this is obviously from the creation ministries, the catchphrases they come up with to kind of weasel out of that, to weasel around it and say, well, we don't really care about the science anyway. We can see here on the screen, science can't be the final determinant of what we consider a plausible account. Now, to me, if we are talking about, and our debate here is there good scientific evidence of a young Earth? And I would agree with what the creation ministries say. I'm interested to see what David's got to say about that later on. But to me, science is everything. So I'm going to be looking for scientific evidence from David in the debate, not theories or ideas about what might or might not have happened, but actual evidence, because that was the title that we agreed on. Is there good scientific evidence? So every single drop of the hat, I'm going to be asking for that. I'll show you what good scientific evidence looks like, actually. Just scroll down here a little bit. To me, this is fantastic scientific evidence of the Earth being old. I'll leave the title on screen, so any creationists watching who want to Google this paper and look at it, feel free. You'll be able to find this. It's freely available online. So this paper is essentially a meta-analysis. And it's a meta-analysis of 57 globally distributed sites. We can see those sites here. And these 57 sites were studied over decades. These are the citations, the references you'll find in that paper that link to each of these sites. 57 different investigations for different over many years. And these investigations used a few different, not the same technique, but a few different techniques to work out dates and temperatures for locations, these 57 locations over the Earth, spanning back hundreds of thousands of years. So some of the things that they used was levels of different isotopes of oxygen in cores that they drilled to look at life in the past as indicators of temperature. Other things they used was uranium-238 in dust, for example. And I know we'll quite often hear from young Earth creationists that we can't trust dating techniques. And what you would find, I think, if you say you can't trust a dating technique, you would find that if 57 people all did tests over different decades who never spoke to each other, didn't know each other, some had even died before the other person had become a scientist, right? There was no communication between them. You would imagine that these errors, right, would throw the results left, right, and center, and everybody would have a completely different idea about what had happened in those previous hundreds of thousands of years. But actually what happens is quite interesting. And to me, this is evidence. Because when you look at the results, and here we have oxygen saturation records going back hundreds of thousand years, and again, they've dated that using the uranium 238 and other techniques. All independent studies, you can read all about it. And when we zoom into them, we can see that every single one of them, this is the page that's set on measuring historic temperature. We can see that every single one of them is coming up with exactly the same conclusions, exactly the same one. And let me just remind you that that is 57 independent studies worldwide by people decades apart, using a variety of different techniques, oxygen saturation, looking at uranium decay as the two main ones that I remember from the study, in all honesty, but there were others. And they've all come up with exactly, not even just a little bit, but exactly the same pattern of temperatures going back for what they've dated as hundreds of thousands of years. Now, for me, that is what I would call actual proper evidence. Somebody has done a large-scale meta-analysis of many studies. What they haven't done is gone out there to find one study or one idea that fits their narrative. They found 57 and put them together and saw that even though they were done at different times, that they agree with each other absolutely, completely. Now, one of the things that may come up in this debate as well is isochron dating. Now, rather than waste anybody's time in the debate, what I'll do is I'll explain what isochron dating is now, because I just think it would be useful for later on. One of the big things people or young Earth creationists like to throw against radioactive dating or radiometric dating is the fact that we can have contamination, is the fact that there is a margin of error, for example, in the lab, in the fact that we get groundwater washing carbon-14 in and out of things, blah, 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 blah. Okay. What we need to know if we're doing some kind of radiometric dating on a sample is, has that sample been closed? Since the very beginning, has there been any influx of parent or daughter, or has there been any outflux of parent or daughter, right? Or has it been closed? Because if we can guarantee it's been closed, then we have to accept its results. And if we can't guarantee it's been closed, then we can't accept its results. So how do we figure out whether something has been closed or not? Well, how long have I got? About 3 minutes?
Yeah, good question. You've got, just about 3 minutes, Catz.
So I've got this little graph on the screen here. And what we can say is at any point, any one time in the world, if we were to take two isotopes, let's say rubidium and strontium-86, okay? Rubidium will decay into strontium-86. Strontium-86 is... was it 87? I've got my two isotopes mixed up. I think 86 is a stable one. You'll have to correct me, David, if I've got that wrong. I think strontium-86 is stable, and the rubidium decays into strontium-87. Right, but the ratio of strontium-86 and strontium-87 in the world at any one point is going to be a constant. So I can take a rock and I can look at all the different minerals in that rock, and I can plot the ratio of the daughter isotope that we're looking for and the stable version of that isotope, and they're going to form a line. Now, why are they going to form a line? What have I got on this x-axis? Well, the x-axis is going to represent the ratio of the parent isotope, the rubidium, that's going to decay into the unstable strontium isotope. And each mineral is going to have a different amount of this parent isotope in it. So we get a graph here where everything's on a nice straight line. And it's on a straight line, remember, because the daughter isotope to stable isotope ratio is just constant in the world. Now, over time, what's going to happen is the parent isotope is going to decay. It's going to reduce. But the daughter isotope is going to increase. And that's going to shift all of these markers we've got. It's going to shift it up top left. Now, over time, if there is absolutely no influx of parent isotope or no daughter isotope being washed out, they are going to remain in a perfectly straight line. And when we find, and we do our isocron data, and we test all the different minerals, and we find that these ratios, when we plot them on a graph, are in a perfectly straight line, that shows us over time that this has been a closed system. If it hasn't been a closed system, what we're going to find is something like this. We're going to find that as daughter isotope has been washed in or out, and as the parent isotope has been washed in or out, they no longer hold a straight line. So when we talk about isochron dating, we can't poo-poo it and dismiss it unless we can give an absolute certain explanation of to how all the minerals in a certain rock can be plotted in this way and give a perfectly straight line and still not be a closed system. Because if we can't do that, then it's not science, it's just denial. That's what it is. So again, you know, I know I haven't provided evidence for an old Earth other than the 57 study thing that I did a couple of minutes ago, which I thought was awesome. But other than that, I really am waiting to be presented with what the agreed title was, which is this. Is there good scientific evidence of a young Earth? So hopefully I'll get some of that. And I'm looking forward to it. And I will stop there.
Okay, Catz, thank you very much for that 12-minute opening statement. David and Catz, that concludes the opening statements for the debate. I appreciate all the points and I appreciate the work put into those opening statements. So with that, we are now moving into the 8-minute uninterrupted rebuttal. And David, we are going to hand it over to you.
Before we do that, you want me to do the spiel?
Sure, yeah.
Okay, great. I just want to let everybody know, especially if it's your first time here at Modern Day Debate, that we are a neutral platform hosting debates on science, religion, and politics, and we want you to feel welcome no matter what walk of life you're from. And if you have a question or a comment from one of tonight's debaters, fire it into the live chat and tag me at Modern Day Debate. Super chats will go to the top of the list. All we ask that you please keep it civil, attack the argument and not the person, as insults will not be read. And our guests are linked in the description below, whether you're listening on YouTube or via the podcast. So click those links if you like what you're hearing, and hit the subscribe button because we have plenty more debates coming your way that you don't want to miss, including tomorrow, I believe we have Snake and CP versus Nathan and Witsa Gets It debating evolution. That's at 8 p.m. Eastern. And then we have the next day at 5 p.m. Eastern, we have Daniel Hakikachu versus Nuria, and they're going to be debating feminism and Islam. So with that, we will go ahead and kick it over to the... Oh, and one more thing. I just want to let everybody know that there's going to be an after show on my channel that is linked in the description below as well. So if you want to continue the conversation there, and I'll see you there. Other than that, I will go ahead and kick it back to Donnie for the rest of the debate.
Great. Kaz, thanks so much. David, we're going to hand it over to you now, and you have 8 minutes for the rebuttal. The floor is yours.
Okay. I appreciate the arguments that Al put forward. I worked with Steve Austin in the 1980s, and I'm aware of his taking that modern volcanic eruption of Mount St. Helens and sending that off to get that 3 million year date. One thing that I need to point out as soon as I get my marker here, there it is. As a geologist, as a mineralogist, you need to be aware that a volcanic rock is composed of minerals, and those minerals are what are separated out from the volcanic rock and dated. Some of the criticism that Al has given about this particular mineral here that was pulled out and got a 3 million year old date on a volcanic eruption that occurred in 1980, his thinking is incorrect in this way. When you're looking at the minerals that are in here, and I noticed that he made a point that the 3 million year date that Dr. Austin published was within the error bars of the method. I'm actually not sure that that's true. And I'll return to that later on. Now, this very elaborate argument that Al made about the different isotopes of oxygen found in benthic sediments. For those of you that are not up on all the vocabulary that is used when it comes to things like benthic and littoral and so forth, let's make sure that you're clear on this. So here's the ocean surface. You've got a continental mass over here. I'll put a tree here to indicate that this is a cross section I'm drawing. And near the shore, there is a zone where most life lives, the littoral zone where the wave action is. And then as you go offshore, there are sediments that are very deep, and I'll simply use the word benthic there. Al was very proud of the fact that there were 57 different cores taken over many years, separated by people that were not working together in any way. And as they took these cores, they captured a oxygen ratio and used that oxygen ratio to determine, among many things, the temperature of the different layers going down. As a creationist and as a flood geologist, we view the rock record as objective scientific data. But the vocabulary, the Pleistocene break, all of these 57 samples were fairly modern. Even me, as a young Earth flood geologist, would consider these benthic sediments here to have formed after the time of the flood. They would have been not on top of, well, they might very deep be on top of Triassic rock, but here it's essentially Pleistocene. It's almost like looking at this. I have two purposes for this map of Louisiana here, but it's almost looking at the part that you can see here. This is the Gulf of Mexico, New Orleans, down here. This is Pleistocene sediments. And so from a flood geology standpoint, this is not a strong argument, Al. I want you to go back to explain to me how polonium-218, that has a half-life of 3 minutes, can end up being found in granitic rocks from the base of the column all the way up to the top of the column, which I saw with Bob Gentry when I was his lab assistant. Why is that not the critical thing? Now I'm looking for my timer here. How much of my 8 minutes do I have left?
You've got just over 2 minutes.
2 minutes. Okay, good. Now, the isochron explanation that Al outlined is certainly the kind of diagram that you would see in freshman geology. The idea of daughter versus parent, starting out this way. If it's a closed system, as time goes on, it will rotate this way, but still the data points will be in a line. My critique of that comes from what is now 50 years of field work as a geologist, where I have had the opportunity, the privilege actually, to travel to Canada and to the Germany, Africa, Turkey. I've been hired as a geologist to go worldwide. What I routinely see in igneous rocks like this has been cut and polished, so it looks very pristine. But when you actually go out and look at the rocks and look at the surface, you could say, well, let's get a sledgehammer and break down to a fresh part. Well, that's a nice
30 seconds.
That's a nice attempt to have a closed system. My experience is that the kinds of rocks that are looked at for rubidium, strontium, for example, actually quite weathered. It's a bad argument, Al.
David McQueen, thank you very much. That wraps up the 8-minute rebuttal. We are now going to hand it back to Catz. Catz, you also have 8 minutes for your rebuttal. And whenever you're ready, the floor is yours.
Brilliant. Well, thanks for that, David. A couple of things I just want to mention so we can get into in the back and forth, so I don't forget. The isochron argument, I just think you missed the point a little bit there. The point is, if we are getting a straight line, it has been a closed system. So we can call it a bad argument, but ultimately, if that line is straight when we plot them, it has been a closed system. So I'd love you in the back and forth to tell me why that is a bad argument. The 57 different studies all around the world, spread by decades, that give identical results. Again, I'd love to go deeper into that, into the back and forth, so you can explain to me exactly why the fact that they get identical results can just be completely handwave dismissed. Those to me are two really big points. So I'm sure you'll have things of your own as well. Anyway, getting to your points. So the halos, talk about these polonium halos. Now, it's well known that, Gentry's, was it Gentry? Was that what he was called? I can't remember his flipping name now. But it's well known that he's never once, and I hope you can provide some evidence for this, he's never once provided any evidence whatsoever that those halos are the result of alpha decay due to polonium. Never once. He has never once provided evidence that. So I'd love for you to say, because remember, this debate is about, is there good scientific evidence for a young Earth? So let's stick to the evidence. I would love you to tell me specifically, what is the evidence that those rings are actually caused by alpha decay from polonium decay? Okay, that will be really, really important. You did ask me as well about why would you find that polonium isotope 218, wasn't it, all the way through the granite? Well, we can't forget that obviously it's part of the uranium decay chain. So it's not that it's there for 3 minutes and then disappears. It's popping up all over the place all the time because it's part of that decay chain. So I'm surprised that you think it's a difficult question to answer, in all honesty with that. So the halos, would I say they are scientific evidence of a young Earth? No, I wouldn't say they're scientific evidence of a young Earth, because there's no scientific evidence whatsoever at all that they're caused by alpha particles from polonium decay, or why that indicates that the Earth can only be 6,000 years old. If you can make that link and tell me why it means the Earth can only be 6,000 years old, and, we'll chat about that, but I don't think there's anything there, so we'll cross that one off. The second argument you made in your opening debate was about population size. You came up with a really nice equation that obviously ignored a lot of things like population density, and how population density is going to reduce the reproduction rate. And obviously in the early days when population was spread very, 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 very thin, and The child mortality rates were obviously extremely, extremely high. People weren't living to the reproductive age. All that was just completely ignored in the calculation you did. And we can all do that. Like, we can all come up with calculations. And I could do one and say, right, by my calculation, I think that the human population now fits the old Earth model. But is that evidence? Remember what the debate was. Remember the title of the debate we agreed on. The title of the debate we agreed on is there good scientific evidence for a young Earth? And I don't think you simply saying, I've got this equation that I think means that the population of humans could be 6,000 years old. That's not evidence. What I brought was evidence of 57 different studies that all agree with each other, spanning decades. That's evidence. The third thing you said, you talked about the dynamo effect. And obviously, when we look at paleomagnetism, and I'm certainly not an expert on paleomagnetism at all, but there are huge, huge records. In fact, I think I've got a study on one of these tabs open if I can share my screen. But when we are talking about evidence, here we go. Oh, was my screen sharing all that time? Right.
No,
okay.
Catz, I'll stop your timer. No, it just shared now.
So no okay, sorry. So I've just found a scientific paper earlier on tonight. Just Google it. This is just one paper, and it's a fantastic. It's the kind of evidence I would be hoping a young Earth creationist will bring to a debate where the title is there good scientific evidence for a young Earth? And if we're going to bring evidence that we don't believe in the dynamo effect that causes the Earth's magnetic core, then bring some kind of scientific paper to back that up. Here's some evidence in the form of a scientific paper that will absolutely disagree with what you're saying. It has, obviously all the hallmarks. I've not read it. I had it earlier on tonight. But that took me about 2 minutes to find. And in preparation for this debate, it seems that you haven't been able to find one scientific paper to back up your claim that the dynamo effect isn't real. And again, if the title of the debate is there scientific evidence for a young Earth, then no, you've not brought it. You've suggested you don't think this dynamo effect is real, which is a suggestion. It's not evidence. Now, with the nickel claim, I'll be absolutely honest. I was making notes of that at the beginning of that bit, and I kind of missed the implication of that. So you might have to run that one by me again with the metals. All I can say is, again, I got the feeling by the end of that bit that it was just an idea, a suggestion. There was no measurement, scientific paper. You know, when the title of the debate is there good scientific evidence? Please bring some scientific evidence, not just ideas. After all, in the opening, I did bring scientific evidence of 57 independent studies taken over many, many decades that all give exactly the same result. So I would say in terms of my rebuttal, no, I haven't seen anything that will constitute scientific evidence as per this moment in the debate. I think I'm done there.
Catz, thank you very much for that 8-minute rebuttal. Gentlemen, that concludes the opening statements and the rebuttals. And great job so far. Very professional, cordial debate. I'm looking forward to Catz and David digging into these points during the discussion portion. But before we get into the 40-minute discussion, we are going to have a 5-minute break. And so, Catz, David, if you'd like to rest for 5 minutes, get a drink, refill your coffee, David, feel free to do so. David, I can unmute you.
To honor my friend across the pond, I'm going to make myself some Earl Grey tea. And so I'll be back in 5 minutes. Go ahead and drop my video, please.
Enjoy.
Okay, David, thank you. Over to you. If you had some announcements or reminders or anything that you wanted to point out to the audience.
Sorry, we're talking to me.
You're talking to me?
Catz.
Oh, no,
well,
I'm sorry. No.
I guess Catz and Catz are pretty.
I just want to remind everybody. Sorry, I'll remind everybody to like, share, and subscribe. The guests are linked in the description below, and I'll go ahead and start the intermission video so that we can step away for a moment.
Okay, I
We're
am
back.
back. I couldn't find a proper saucer for my tea, but since my great-grandfather came over from Scotland, I hope you'll forgive me if I don't do high tea quite correctly.
We'll forgive you because the discussion portion will be a discussion to remember. So, Catz and David, appreciate your openings and rebuttals. Again, I appreciate the work you both put into this debate on evidence of a young Earth. And so we're now moving into everybody's favorite part of a debate, the discussion portion. And so we've got 40 minutes on the clock for the discussion. Catz just ended with his 8-minute rebuttal. And so, David, why don't we allow you to ask the first question or pick the first topic to discuss? Go ahead, gentlemen. Floor is yours.
And the way we work it, Donnie, is I will pose a question, and then Al will respond. And then will I have the last word of each cycle, or how does that work?
Well, it'll be more free-flowing. And so
really?
you can ask a question, pick a topic. I'll make sure as moderator that we're not spending too much time on any one point.
Okay.
And that we're moving along smoothly. Actually, Kaz, if you wanted to restart the timer, and we will officially start the 40 minutes now. David, feel free to pick the first topic. Floor is yours.
Okay. First topic I want to pick is the radioactive halo topic. And I want to challenge Al's contention that you can't go to literature that has been in refereed journals to find evidence for a young Earth. And so the article I'm going to refer to is one that I was at Gentry's side when he sent this off. This is published in Science Magazine, 5 April 74, pages 62 to 66. You want to Google it while I'm talking here. So this is Science Magazine, refereed journal, 5 April 74, volume 184. And the title of Gentry's paper was Radio Halos in a Radiochronological and Cosmological Perspective. And in this paper, he argues that you really can tell the difference between a uranium halo having many rings and a polonium halo having only 1, 2, or 3. But the key that I want to go to is some calculus that Al I have talked about on other occasions. And I'm not going to write the calculus up on the board, but I'll let you read it yourself. When you find the paper, you'll notice that footnote 16 addresses your critique that these halos are not from alpha decay. But notice what it says here. From alpha decay theory, the delta lambda over lambda, that's the change in the radioactive decay rate, is proportional to the energy that is expended when these radioactive elements undergo alpha decay. And I'll skip down to the bottom because this is what I want you to react to, Al. Gentry realized in this paper that you could only do so much, and this is the way he said it. If the minimum uncertainty in making the range measurement is about 1/10 of a micron, it's actually impossible to establish the constancy of lambda for U-238 any better than 0.35%. And so here's an example, Al, of a published paper that argues for the age of the Earth being incorrectly calculated at least to the level of 35%.
So my sorry, I don't want to interrupt.
You're good, Catz. Go ahead.
Yeah.
Take as much time as
So
you need.
my couple of points with that. First one, yeah, it's the paper that Gentry wrote himself, of course, and the model that he used was obviously based on an ideal perfect atom, rather than a more sophisticated model of an atom. So it was certainly an assumption. But I would just love if you could give me a really honest yes or no answer to this question. We'll go on, okay? The answer, the question is, did he ever prove, not assume or suggest, but did he ever prove and provide evidence that proves that those halos are formed by alpha decay by polonium? Did he ever prove that?
Let me give you a
just
reference.
Yes or no, if possible. Just so we
yes, he did.
Brilliant.
He did
I'd
prove
love to hear
it,
the proof then. Yeah, go on.
Let me give you the page number. It's that same paper, and you'll find it on his table 1. And the reason that table 1's important is that he and I would go to the electron microprobe there at Oak Ridge National Labs, and he would actually move the probe over. I can use this as a teaching tool. He would move the probe beam over to a uranium thorium atom and look at the amount of lead there. And then he'd move it over to one of the polonium atoms. Well, if all the polonium halos were the result of alpha decay from uranium, that lead-lead ratio would have been clear. I mean, it would clearly show it was a daughter of the uranium. But this paper shows that it was not.
So
how there's actual data.
Sorry, go on.
There's actual data in the lead-lead ratios to show that the polonium halo 218, for example, is not just part of the uranium decay chain.
Okay, so I know polonium 218 will exist other than in the uranium decay chain, but the question was specifically, how did he prove that they must have been the result of alpha emission from polonium 218? How is that proof that it absolutely had to be emission of due to the emission of alpha decay from polonium 218?
Okay. Take me a minute to find it, but one of the papers, the nice thing about this book is that all these papers are bound in this book, and the scientific technique he used for that was fission track analysis. And so by using fission track analysis, he was able to show that the lead-lead ratios were not part of the uranium decay chain.
Okay, so how does that prove that the halos are from polonium 218? How is that proof? Because remember, the time of the debate is this a good scientific evidence? And I know that this is his assertion, but the reason I'm asking this is because everybody else disagrees with him, and there are many, many other ideas of how these have formed and why they are so, widespread. And I'm sure that you've read all of these. I'm sure that you're familiar with the counter arguments. So I won't throw those at you. But how is it actually proof that they're formed from polonium 218? Because of alpha emission, and why does that therefore mean that the Earth must be a young Earth? Because
let me make a comment. It's not true that everyone disagrees with me. My retired kindergarten teacher wife, she's convinced that it's true. I've got a 4-year-old granddaughter named Hannah. She's convinced that it's true. But all joking to one side, this issue has been brought up by Dr. Larry Vardaman and others that worked on ICR's RATE project around the year 2000. Tremendous amount of effort went into it. And one of the things that I'll point out is that if I'm claiming that this is evidence for an old Earth evidence for a young Earth scientifically, it's important to also note that some of my creation science colleagues, like Dr. Steve Austin, like Dr. Andrew Snelling, these men disagree with my viewpoint. But I think that my colleagues, even on the creationist side, are overlooking the fact of a very old challenge that Bob Gentry made to the scientific community. He said, and he argued this with Professor Dalrymple, who was one of his biggest critics. He said, I don't question that you can put some quartz and feldspar and mica in a very small capsule, heat it to high temperature and pressure, and come out with a glass that has the chemistry of a granite. His challenge, and my challenge, I agree with it, is this is about a fist-sized piece of granite. Produce that with uranium halos in it and so forth. Now, Dalrymple and the others said, oh, McQueen, it would cost too much money to build a machine to produce that size. What's the point? The point is that, and this is an area that I even pointed out 50 years ago was a weakness with Gentry, and that's the geologic term provenance. How did he know that this particular pegmatite was found in the Precambrian and this in the Paleozoic and this and so forth? Well, he traveled worldwide and gathered these from different labs. I think that given time, I mean, if we had more time, I could show you papers which show that the different zones that he got these from really are Paleozoic, Mesozoic, and Cenozoic in the old Earth vocabulary. So I think that your critique of me is incorrect because science runs on what's called multiple working hypotheses. And so this data would fit a multiple working hypothesis.
So by your own admission, and I just, and obviously, you know, please don't take anything I'm saying here personally. I've got a lot of respect for you, and I think we've got on well and whatnot. But by your own admission, the halos that you've brought up for polonium are actually not good evidence that the Earth is young, because a huge portion of the scientific community, or almost the majority of the scientific community, completely disagree. But also a significant portion of the creationist science community also disagree with you. And although there may be papers that you might be able to find to show that it's evidence of a young Earth, you haven't brought them to the debate, which is titled, "Is there good scientific evidence for a young Earth?" So,
are you being a bit harsh? I mean, Science Magazine is a peer-reviewed magazine, and this would constitute data.
Absolutely, his paper was absolutely peer-reviewed and published and put in a journal. And then, of course, as you know, about scientific dialogue and even post-publishing peer review and critique, the scientific world didn't agree. And there's so many other problems that it brings up. But like you said, we know those problems because even in your own words, even a huge portion of the creationist science community disagree. So, I guess what I'm saying is, yes, you might say that you've got these papers, but you haven't brought them. So in terms of the debate itself, like you cannot prove in this debate that they are good scientific evidence for a young Earth within the context of this debate. Let's say that. I
understand what you're saying, Al. Let's go on to another point. Why don't you pick one this time?
Yeah, okay. I was really interested in your response to the isochron dating. I know you said, because you said, well, that's a really bad example. But you said it was a bad example without explaining how you can. Now, I don't know if I can share my screen here, only just for the image, really.
We can definitely share your screen, Catz, if you're.
Oh, I mean, I don't know if I'm competent enough, is what I mean.
Oh, okay.
I know you can. I don't know if I can. It's late here. Right, so I've got it up ready now. So, for those who are new to the debate, I brought this up in the opening about how when we take these different minerals and we measure ratios of parent and daughter isotopes and also the stable version of a daughter isotope, that we can show that a system is closed to contamination or leakage if these, when we plot them on a graph, as you can see in front of you, if they form a straight line. You'll have to go back and look at the beginning if you didn't see why that was evidence. Now, I know in the rebuttal, David said he wasn't impressed by that, but what I didn't hear in the rebuttal, and what I'd really like to hear in the rebuttal, is how you can get them plotted on a straight line and it not be a system that hasn't had any contamination.
Okay, let me respond to that.
Yeah, you can pull it down if you want now, Don, the thing.
Yeah, go ahead and give me my screen back there, and I'll show the audience what my argument is. Here's the daughter products. Here are the parent products. The isochron is drawn as a line between the other data points. And fitting a line to these data points is a standard statistical technique. Okay. My problem with this as a field geologist with 50 years experience now is when I've gone out to look, for example, in my years in the 1980s, I hiked the Grand Canyon 5 times in 4 years. So some of the very lava flows that Steve Austin and Larry Vardaman and others looked at in the Grand Canyon, I've actually seen them with my own eyes and looked at them in outcrop. And when you look at these places where the rocks are actually collected, you have to ask yourself the 3 basic questions. Has the radioactive decay rate remained constant? I think the answer is no, at least within 35%. Has there been anything added or subtracted during the time of a billion-year-old Earth? And when you focus on that one, that second one, about leaching or addition, as I've gone out looking at copper, lead, zinc, gold, silver deposits, some of which are even in the Grand Canyon, the weathering and the fracturing of these rocks over. Now, keep in mind, I was trained traditionally, believing that the Earth was billions of years old and the rocks are millions of years old. When you look at this, there is ample opportunity, Al, to see this. And the way that you see it in practice is you can see a stain. Does that help you understand my critique?
No, I think with all due respect, and I do know that you've worked professionally in the field, and I do have a lot of respect for that. But with all due respect, I think it doesn't answer the question at all. The question is that when we take one of these rocks and we analyze the minerals and we plot the ratio, just like if you can just put the screen up again, Donnie, just so people who are new can see the graph. But when you plot these data points from the different minerals in the rock, when they form a straight line, that shows, like I explained at the beginning, and if anyone's new, they want to wind back and watch, that shows that there hasn't been contamination. Now, what you seem to be saying is when you look at a rock, rocks can be contaminated. Well, what I'm saying to you is if the rock was contaminated, this is what we get. This is the test. Now, I'm not sure. I don't know. Maybe you haven't heard of isochron data before. I don't know. But if contamination has occurred, this is what we get. We don't get this. We get this. And this is what I'm asking. You seem to be saying, yes, rocks can be contaminated.
I think I can better explain. Let me redraw my diagram here. You have commented that if there is contamination, when you draw the graph, you should get a data point here, a data point there, a data point there, a data point there.
No, that's not what I'm saying.
Well, let me just finish my point. If these were the data points, the statisticians would fit a line to that.
No.
But that line, and let me use a different color here, that line would not be the same. And you know the statistic as well as I do. You can calculate the how good a fit it is. You seem to indicate that the fit will be more like this. And because the isochron goes that way, that proves that there's no contamination.
Can I clarify? Can I clarify? Because I think
yeah,
we're talking
please.
slightly about two different things. Donnie, are you okay? Sorry, Stanley, are you okay to perhaps put the thing back up here? Why don't we just give a very brief explanation of what I mean? Maybe we are slightly at cross wires. Maybe we're not. Maybe it's me. Okay. But what I'm saying is at any one point in time, if we were to take the ratio now of strontium 87 and strontium 86 in the world right now, that's in the process of forming whatever minerals it's in the process of forming, that's going to be a constant, isn't it? So whatever mineral, if I've got a rock here and there are minerals forming inside this, newly forming rock right in front of me, the ratio of the of strontium 86, strontium 87 is going to be the same. So if I was to plot that ratio on a graph, it would form this straight line that I'm just going to draw myself another thing here. This straight line I've got across here, right? That they are the line that they would form. And what I'm saying is on the bottom, right, we have the parent isotope, which is the rubidium that decays into the strontium. Okay. And this is a ratio against a stable daughter isotope as well. But basically consider this to be the amount of parent isotope. All right. So what we would get at the beginning of the formation of the rock, we know at the beginning of the formation of the rock that these would have formed a straight line, because we know that the ratio of those isotopes at any one time will be the same. Okay. What I'm saying is over time, as the parent isotope decays, we are going to get less parent isotope, more daughter isotope. So all of these minerals are going to start to move upwards to the left. Now, if there's no contamination, they will all move upwards to the left by the same proportion dictated by these ratios if there's no contamination. So if they fall on a line here, we know that there's been no contamination. But if there has been contamination over time, they will be here. Now, what you seem to have drawn on the graph there is something like this and said, oh, well, we've just drawn a line of best fit. Well, no, if this is what we see, then we know there's been contamination and we chuck it out. We don't consider using this for dating purposes because we can see there's been contamination. But if we see it falls perfectly like this, then in that instance, we use it for radioactive dating purposes. So I know where you were going with this, but if it looks like that and it's not a perfect line, we throw it out, don't we? We don't use it. We discard it. That's where I'm going with this.
Now I could see how to further clarify the thinking. See, an example, as a young geologist, I worked in the southern Appalachian Mountains. This would have been northeast of Atlanta, Georgia, east of Chattanooga, Tennessee. And there's a group of marbles in that area that's called the Murphy Marble Belt. And it is surrounded by a very complicated group of metamorphic rocks. Well, radiometric dating of that Murphy Marble Belt that was done, I guess it must have been done in the 60s. The radiometric dating that was done in that...
was it isochron dating? Because if it wasn't isochron dating, then it's not relevant.
I think it was, but just give me a minute of leeway here.
Okay.
The date that was obtained was, I think, 1 billion years. Further geologic work discovered a trilobite very rare to find any kind of fossil in a metamorphic rock, but a trilobite was discovered. And so the senior geologist that was my mentor at that time, I asked him, well, what are you going to do about this? He said, oh, well, the index fossil always is a trump card over any kind of radiometric date. So that automatically became Cambrian, or 500 million years, over the billion-year radiometric date. I do not know the answer to your question as to whether it was done as an isochron. But what I'm trying to say is, traditionally trained geologists realize that very few of their colleagues in very few labs worldwide even actually do radiometric dating. And so in a sense, they're at their mercy in one way. And if they're shown an index fossil, which they remember from their training, they're always going to go with the index fossil. Now, I've been misunderstood in previous debates. I'm not saying that there is some worldwide conspiracy of people that run labs. All I'm saying is that when you point out that if you get a bad graph, you throw it out, sometimes they throw it out because it's given them a date that is not compatible with the standard geologic column.
Okay.
Go ahead, Kat.
I think we've gone way off. I think, and you know, we can move on topics, but I think what I've shown there is that there is no young Earth creationist rebuttal to the isochron dating. You know, I think I've tried 2 or 3 times to explain why, when they fall on a straight line, that shows that there's no contamination or leaching, and I don't think I've had a straight answer either way. I think each time we've sort of swerved and dodged, and I really don't think ultimately the end of.
Let's go to another topic. I think you're right on that.
Yeah, I'll just go back 20 seconds, and then I'll go. But at the end of that, it was interesting that you talked about labs and not being many labs that do radioactive dating in the world. Can you possibly, standing for two, please just share my screen? In a debate you had just at the tail end of last year with King Crocoduck, I know you did mention that you felt that at a ground level, people would feel the need for a bit of bias if they were in the lab because they didn't want to lose their job. If they found that something was, in fact, one of your quotes, I've got it written down here, is that some bloke in his 50s will be doing this and he wants to pay for his Mercedes and send his young girl to a good university, was your exact words. I've got that written down. And so that what they would do is that they would inflict their own bias on the results. And King Crocoduck brought up, this is a screenshot, this fantastic thing here where he showed you how you can use this funnel. Forget the term of it now. I was going to pinch his argument, but I've got to give him credit. It was a brilliant argument. But this kind of a funnel analysis to show that actually you can test scientific papers to see if there is bias or there isn't bias in an area. And he did it on the debate, and he showed you that there was no bias. And I remember, because I did note it down, it was about 50 odd minutes into the debate, you said that you were going to look into it and you'd be ready to discuss this bias in about January or February when you debated it. So have you looked into this? Yeah,
I have looked into it. And with the help of George Bond in Australia, what we've discovered is that this statistical technique is primarily used in a marketing setting. This statistical technique is very rarely used to determine something like isotope ratios.
Instead, but that's not what it was for. So it wasn't isotope ratios. So if I can clarify, it wasn't isotope ratios. It was the bias in the reporting from labs on radiometric dating. So it wasn't taking a scientific analysis. It was just taking an analysis of the science that was done. So it was taking an analysis of the results that were reported. And King Crocoduck did a very, very good job of explaining it. Go and check out the debate. It's on the Modern Day Debate channel.
I am still studying this. My critique is that he's taking a statistical technique basically used for marketing to try to find out who's going to buy mammography devices, and applied that to a scientific.
Okay, if I could jump in real quick, David, I appreciate that. Catz, because the isochron point and topic is very important in light of tonight's debate question, can you both, so Catz, take 2 minutes all time to reiterate your points on isochron, conclude that topic, point out why it's good evidence against a young Earth and for an old Earth. And then, David, I want you to take 2 minutes to respond as clearly and in a concise manner as you can to that. And then in the final 10 minutes of the discussion, we'll move on to a third and final topic, if that works for you, gentlemen.
Yeah, no problem.
Perfect. Yeah. No, good move. So essentially, the reason it's important to me is that young Earth creationism seems to handwave dismiss radiometric dating techniques because they can say, oh, contamination, or there's leaching of parent or daughter into the sample, or leaching of daughter or parent isotopes out of the sample. So it's unreliable. And I remember in David's last debate against, again, King Crocodile here, he said his entire problem with radiometric dating was he wasn't sure of the amount of parent sample, or to be more specific, even the ratio of parent sample to daughter sample. And I think I've outlined, people can always wind back and watch, I think I've outlined that isochron dating is a brilliant, perfect technique to establish that there has been no leaching in or out. Absolutely no leaching in or out. So therefore, when you find a sample like that you've proven has been a closed sample, you can rely on the radiometric dates that you get from it. And I think I've proven in the conversation with David that actually there doesn't seem to be any kind of argument against it at all. And that's my point in a nutshell.
Catz, I appreciate that. That's just over a minute. David, if you'd like to respond between 1 and 2 minutes on isochron specifically, and then we're going to pick one final topic as we wind down the discussion. Go ahead.
No
David.
problem. Dr. John Morris, who sadly passed away last month, wrote a book called The Young Earth. And on page 57 of the book, he actually created a chart, Al, giving the whole rock isochron ages of a number of different rocks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. But I'll just pick one that I have seen with my own eyes. This basalt from the Grand Canyon. It's from the eastern Grand Canyon. Conventional age about 1 billion years old. And then he has the model ages, but more importantly, let me read you the whole rock isochron ages of that particular basalt, method by method. And I'm rounding for purposes of our discussion. Potassium argon whole rock isochron date was 516. Rubidium strontium, 2 different specimens, 292 million to 1,100,000. Samarium, neodymium numbers, 1 billion, 1.3 billion, very consistent among the samples. Lead isochron date, 1.2 billion, 1.3 billion, 1.5 billion. And I hope you notice that almost all of these whole rock isochron ages are higher than the 1.1 billion conventional age. What do you make of that?
So when you say ranges, a range of course, obviously over in the UK here, when we talk about a range, we're talking about a difference between the highest figure and the lowest figure. So when you say range, so the range of what, like, if you're not showing me what the lowest and highest figures are, then just giving me the range. Like, I could say to you, I've got a range of £10 in my bank account. It could mean I've got £2 or £12, or it could mean I've got £1 million or £1,010,000. So let me
help on that, because we've talked a lot about rubidium strontium. So let me just focus on that one. again, the conventional age is 1.1 billion, and the rubidium strontium age they got from two different samples range from 892 million to 1.1 billion. And so there's no agreement there on the whole rock isochron age.
So you're looking at
that significant.
20% maybe out. 25 to 30% maybe. Which I think when you and if we were saying that the Earth was 6,000 years old, that would be a huge percentage to be out. But if something is saying, well, it's between 800 million, and we said we started the debate by saying that these labs have and you agreed because you said you were there when Austin handed that rock to the lab, and you agreed that there was a 3 million year thing either way. So you know that there are big margins of error either way. And if we're going back 800 million years, then yeah, okay, let's give you 300 million years and say it's 500 million years old. It's still way more than 6,000. It doesn't go in your favor, and if anything, it destroys the idea of a younger. So I'm not really sure. I think reading those figures out has actually destroyed your argument rather than saved it, I think.
Okay, let me jump in, gentlemen, just because I'm looking at the time. To be fair, David, why don't you take a quick response? And then I think we have to move on to the final point, as there were many points brought up in the openings. And then to be as fair as possible for that next point, we'll give Catz the last word on that one as we move into closing statements, if that works for you, gentlemen,
that's fine.
David and Catz.
And the last thing I'll say to Al is, if you don't have this book on your shelf, this would be a good one to actually give the data from those whole rock isochron things.
Hey, I've got this one on my shelf, and I wrote it. Just be up on my website.
So what's the name of your book?
At the minute, it's got a working title of High School Physics. We're gonna have to come up with a better one.
Oh, okay. Well, that'd be a good one to buy. Back to you, Donnie.
Okay, so what we'll do, David picked the first topic, Catz picked the second topic. David, in your opening statement, correct me if I'm wrong, you looked to 3 or 4 major points. And so for the final 5 minutes here, Catz, if you wanted to put on Kaz, not Catz, if you wanted to put 5 minutes and we'll discuss one final point, David will allow you to now pick that point and we'll go back and forth for 5 minutes. Go ahead.
Al had commented earlier that my explanation of the volume of metallic ore of something like nickel was a kind of a confusing argument for why that would indicate that the Earth is young. So let me go back to that argument with some discussion of what in geology we call sedimentology. It's been well known by sedimentologists that billions of tons of sediment are washed from continental masses into the sea each year. Calculations by oceanographers have actually been done that there are 820 million billion tons of sediment worldwide in the modern ocean. Now, the problem for that and how it indicates a young Earth is in the old Earth evolutionary plate tectonics model, the maximum age of most ocean basins are about 300 million years old. Now, the mass of rock that's going in contains different elements: potassium, copper, lead, zinc, gold, silver, called crustal abundance. Well, if we focus on this mineral, nickel, which is without question found in large cratonic areas like the Upper Peninsula of Michigan and in Africa and so forth, huge nickel deposits. If we look at those and say, well, if the Atlantic Ocean is the Jurassic Age, and We have continental separation beginning anywhere between 150 and 70 million years old. There's not enough nickel in those sediments in the Atlantic, for example, to account for an old Earth. In contrast, the amount of nickel in those areas can be explained by a few thousand years of erosion. Does that help?
Yeah, I'm not really sure in what way, how that's, because remember the title of the debate is the good scientific evidence, you know,
Yes.
And I think what you presented there with no calculations, you know, it's okay to say young Earth creationist calculations say this is going to fit, and young Earth creationist calculations say it doesn't fit in old Earth, but really, you know, in a debate where we're supposed to be looking at actual scientific evidence, that's more of an anecdote, you know, and obviously, quick Google there while you were talking that most of the naturally found nickel on Earth is sort of in the southern hemisphere, you know, Australia, South Africa, although there is some in Russia and Canada, and so I don't know. It seems odd to me that you're saying, oh, there seems to be a lack of it in the middle of the Atlantic. When it's taken me 2 minutes even just to look and see, well, actually the majority of it isn't found anywhere near there anyway. There's no calculations with what you've said, so I don't see any way I can take what you've just said as good scientific evidence, which was the title of the debate. Good scientific evidence for a young Earth, and I just don't see how that's good scientific evidence with no calculation, no paper. I just see it as an anecdote.
Am I allowed to make a comment, Donnie?
Go ahead, David. Yeah, we still got a couple minutes left.
Yeah. My critique of what you say, Al, is I have visited the huge nickel mine in Sudbury, Ontario, Canada. I've been close. I haven't actually gone to the one. I've done some field work in Zimbabwe, but I didn't get down all the way to see the huge nickel deposits down in the Bushveld area there. So I know that in rocks without fossils, Precambrian rocks, there are found these huge nickel deposits. And I'm aware that they are on continental masses. But that doesn't negate the point that we can make modern calculations, and they are published in the oceanographic literature, about how much erosion from the land masses go in. And the erosion of those land masses would certainly include, for example, the Sudbury deposits eventually filling into the Mississippi River Valley, river basin, and out to the Gulf of Mexico. So I think there's better science behind this than you might think, Al.
Okay, I'm going to jump in real quick. To be completely fair, Catz, now you get the final word on this point, and so feel free. Go ahead, take your time.
Thank you. So yeah, I mean, there very well may be better science on it, and my kind of point on this would be that if we're having a debate on is there good scientific evidence of an old Earth, of a young Earth, and you bring to the debate of is there good scientific evidence for young Earth, if one of your talking points is nickel deposits, if then when I question that, we have to say, well, there's probably, but you know, if your response to that is, well, there's probably some good evidence somewhere, then I would say that you haven't seen that evidence and you haven't brought that evidence to the debate. And I can only take your word for it that there's good scientific evidence somewhere, but nobody here has seen it and nobody watching has seen it.
Gentlemen, I appreciate the discussion. I could probably listen to this for another 40 minutes, but we do have to move on. And so, David, if there is anything you'd like to respond there to what Catz said, save it for your closing statement, because, gentlemen, we do still have 5 minutes each to wrap up our thoughts, wrap up our points, and address anything that we feel may not have been addressed adequately. So, David, you do get the first 5 minutes, and then Kat, you get 5 minutes. And then we are going to get into some audience questions that Kaz, thank you very much, Kaz, for being diligent. He has saved a bunch of audience questions. So, David, whenever you're ready, the floor is yours. 5 minutes.
Once again, I'll begin my 5-minute close by complimenting Al. A very good job in presenting your arguments. I do not believe that your conclusion is correct, and we'll talk about that more with some audience questions. But because I approach this standing for truth opportunity that Donnie has given me, my focus generally is to find evidence for biblical truth about things. And so when I have my Bible in my hand, I think an interesting topic for you and I in the summer to talk about, Al, is not the religious aspects of Moses and Jesus and all that sort of thing, but rather the archaeological and historical evidences that the different parts of the Bible can be trusted. And so when I think about the evidences that you've presented, it reminds me of something that Jesus said, building up to the time of his crucifixion. Easter is not that far away. In Matthew 24, he says, "For in the days that were before the flood, they were eating and drinking and marrying, giving in marriage. Things were going on just like normal. And they knew not," I left out something there, "until the day that Noah entered the ark, and knew not until the flood came and took them all away. So shall it be in the coming of the Son of Man." Now, what interests me from a historical standpoint, at least I think we can agree that Jesus was a historical figure. And here he is referring back to events in Genesis. And so I think the argument that I've given to others over the last year that the Bible is a trustworthy historical document is well taken. Now, how much of my 5 minutes do I have left?
You got about 2 minutes and 2.5 minutes.
2.5 minutes. Okay. Let me quickly go back over these points. Science is not done by majority opinion. Majority opinion comes into play in a lot of parts of life, but not in science. And so just because there are a lot of people that disagree with Gentry's work about the halos doesn't make his work wrong. Dalrymple's critique that there might have been some problem with our measurements is simply wrong. I was there. I made some of the measurements. I know that they're within the accuracy of the microscope. This issue of population statistics is fascinating to me and important. We're often challenged. Well, McQueen, there's 8 billion people on Earth. Then we're going to run out of room. If you go to National Geographic and pull up a map of Louisiana, this is the black areas where I live. We have parishes here instead of counties. It turns out that National Geographic points out that if everyone on Earth stood shoulder to shoulder with no room at all between us, we could all fit within that black area there. So the idea of population statistics is, I think, widely misunderstood by people. And if evolution were true, we'd have a lot more people. The decay of the Earth's magnetic field, modern 21st century creationists recognize that there are magnetic reversals. And we may address that with some of the questions later on. So the issue is not that there's never been a magnetic reversal. The issue is that this right-hand rule is an argument against the dynamo theory. And I think we've talked enough about the volume of nickel. Very much have appreciated the opportunity to summarize the scientific side of a young Earth.
David, thank you very much for that 5-minute closing statement. We're now moving on to Catz. Catz, you also get your 5-minute closing statement. Whenever you're ready, the floor is yours.
I don't think I'll need 5 minutes. I do want to thank David. He's been ultra civil in the email exchanges building up to this debate, as is standing for truth. Obviously, got a lot of respect for both of them. David, in terms of your offering to debate me on the archaeological comments in the Bible, I think you'd rip me apart if we did that. So I'm going to decline. I don't think I'd be able to live with you.
Oh, you're too harsh. You're too hard on yourself.
But maybe we could find something else to talk about. As far as it goes with the science, I opened up this debate for those that were there at the beginning, and I said that normally I debate people who are just blatantly wrong, flat earthers, people that deny viruses exist, they're just absolute numbnuts. And often they will sit there and they'll say, prove to me the earth isn't flat. Prove to me it's a globe. Prove to me viruses exist. And it doesn't matter how many scientific papers you throw at them, how many satellite images, how many whatever, how many scientific laws that you explain to them, they'll sit there and not understand any of it and just say, oh, that's not good enough for me. So to be on the receiving end of that tonight, I thought that would be good. The title of the debate was, is there scientific evidence for a young Earth, or is there good scientific evidence for a young Earth? And I thought that I would have scientific papers thrown at me. And that didn't happen. In fact, it was me in the opening statement that brought the scientific papers. I thought I would have established scientific arguments thrown at me, but that didn't happen. It was me using, for example, the isochron dating that brought the scientific arguments. And, as much as I respect David, as much as I respect standing for truth, and I'm not coming here to bash religion or anything like that. I never tell anybody if I'm an atheist or a Christian or whatnot, because to me, it doesn't matter. It's about the science. You can believe that you can believe I'm a Satanist. You can believe I'm a Christian. It doesn't matter as long as you think that I've argued the science. That's all important to me. And I just don't think that there's been any science offered tonight whatsoever. There's been opinions. There's been kind of assumptions. Well, what if the dynamo effect is wrong? Or what if the population kind of expanded in this way? But for the debate to have the title, is there good scientific evidence for a young Earth? Well, clearly not. And that's that.
Okay, Catz, thank you very much for your concluding statement. Gentlemen, that concludes the concluding statements and the debate itself. I do want to thank you both for the work, time, and effort you put into prepping for this debate, Catz and David. Always cordial, always professional, and I enjoy the technical back and forth as this exchange was. So time has flown by, and we do have about 25 minutes worth of audience questions, which Kaz has saved for us. Kaz, I wanted to ask you real quick. I saw a couple more super chats just come in. Have those been added to the Google Doc, or did you want me to add them right now?
I'm adding them. I'm adding them right now.
Okay. Okay, perfect. Okay, well, we're going to just move into some audience questions then. Kaz, did you want to start with, I've noticed that there's some super chats, more so just with some statements and not necessarily questions. Do we start with those, or how does it typically
I think
go
we usually
here
try to do them in order if they're a super chat.
Okay.
Yeah.
Okay, and if I know you had somewhere to be once the Q&A starts, so I'll just start at the top then. And Kaz, I appreciate your co-hosting and co-modding here. And so we're going to start right from the top and get into these questions and statements. So, okay, so first one that comes in, unless Kaz, was there any final words you wanted to say before you got out of here?
That's okay. I'm going to have to, I'll try to jump back in at the end of it if I can.
Perfect. Okay. Appreciate it. Okay, here we go, guys. We are going to get right into it. So Thuros Rex, $2 super chat, says, will also happily debate evolution. Come at me. So, okay, thank you for that. And I know Modern Day Debate does host debates on evolution. I host debates on evolution over on my channel. And so anyone interested in that topic, we'll be happy to do that. Okay, next one comes in. Thuros Rex again, $10 super chat. He says, geologist here. The Earth is over 4 billion years old, and the methods we use to determine that are accurate beyond reasonable doubt. Happy to debate this. I have an open challenge on the Discord. Well, since I guess it's more so directed at you, David, more so just some comments, but we'll give you the opportunity to respond if you'd like to.
Okay, good. This individual doesn't understand some basic geology. No terrestrial rocks, even given the radiometric dating that Al and I have talked about, no terrestrial rocks actually date to 4.5 billion years old. That date comes from, in the old days, it came from meteorites that had entered the Earth's atmosphere. Up in the Apollo age, I had the thrill of seeing Apollo 12 blast off when I was a teenager. And once they got those rocks back, they dated them, dating essentially the age of the moon, as 4.5 billion years. And so my newfound friend on this debate channel, get your facts straight before you make statements as broad as, oh, we know that the Earth is 4.5 billion years old. Point to me a terrestrial rock of that date.
Thank you, David. Catz, was there anything you wanted to add or contribute to that comment?
Just that we know for a fact it's far older than 6,000 years old. You know, I think even as David showed when he was reading out the isochron and he was saying that there was a margin of error, and it was between 800 million and this rock and just over 1 billion years old. You know, I think that kind of information. You know, I think it's very obviously not a young Earth.
Okay, Catz and David, let's move on now. Typically with the questions, what we'll do, these are just comments, so you both got a response. When we actually get to the questions themselves, let's say it's for you, Catz, we'll allow you to respond quick. David, you get a response, and then Catz would get the last word. But since these so far are just comments, we'll just keep moving on. So next one comes in from Psycho Octopus the Thing, $2 super chat. Thank you so much. This individual says, appreciate the mods and debate participants. Thank you. Well, thank you to the audience. You guys are the life and blood of these debate channels. Lorraine Drosophila, $2 super chat. Good to see you, Lorraine. She frequently participates in my live chats as well. And she says, David McQueen, what does 6,000 years worth of decay look like?
Okay, it's a very interesting way to ask that question, and the way I would answer it is in this regard. When I go with my grandchildren to the beaches of the southern United States, near Florida and so forth, we often walk on the beach and see plesiopods, gastropods, clams, and snails that have been washed up the previous night. The clams, the plesiopods, are generally open shells, but if you look at the science of clams or plesiopods, they have two parts, not really equal in size, but two parts that are held together by a ligament. So 6,000 years worth of decay would indicate that most of the plesiopods that we find, whether we find them out in the water off the White Cliffs of Dover, or we find them in Turkey, or we find them worldwide, most of those plesiopods are going to have that two parts broken. As a flood geologist, what's interesting to me is I have seen with my own eyes worldwide beds of plesiopods, gastropods, well, gastropods not a good, beds of plesiopods that have been buried very rapidly, and both shells are there, evidence of catastrophic deposition. That's how I would answer how you can find evidence for the Great Flood in these fossils. And then if you go into our modern world, whether it's Charles Darwin walking in 1859 or you and I walking now, you're going to find a lot of creatures that are busted apart.
David, thanks for the response. Catz, the floor is yours if there's anything you'd like to add.
What was the question? Just very quick. Sorry, what was it?
No worries. Let me pull it up again.
I was reading the comments on the screen.
No worries. So the question was specifically to McQueen, but it was from Lorraine, and she was asking, what does 6,000 years worth of decay look like?
Okay. Yeah, no comment on that one then. No comment.
Okay. Appreciate it. So we will move on. So the next one comes in from Infini Ryu. $5 super chat. Thank you so much for supporting Modern Day Debate. Question is Appalachian Mountains ? That's where me and my sister went on our first date. So thank you for that. Okay, moving on to the next one. Thuros Rex, $5 super chat. And Thuros Rex is coming at you, David. So we'll give you the opportunity to respond however you feel fit. And Thuros says, David, you're wrong saying an index fossil trumps dating. Entirely wrong, this individual says. I've had multiple professors older than you say the complete opposite. So what are your thoughts to that, David?
Well, first, my regards to your professors. I turned 70 years old this summer. If they're older than I am, I hope they can still get up and down to make their comments. But joking to one side, if you go to the geologic literature, and you can easily Google this very famous group of marbles in the Appalachian Mountains. And if you Google the MURPHY, Murphy Marble Belt, if you look through that literature from about 1965 through about 1980, for example, you'll find an actual fascinating debate over the contrast between this trilobite that was found there and the radiometric date. The old Earth community went nuts over this because a lot of traditionally trained geologists, like my mentor with the United States Geological Survey, would always accept the Cambrian trilobite to be 500 to 600 million years old and immediately dismiss the old Earth viewpoint. So the way that traditionally trained geologists have viewed index fossils, look this up. I think you'll find it an interesting read.
Thank you, David. Moving on, unless Catz, there's something you wanted to add.
No, that's fine.
Okay, appreciate it. We're moving along smoothly. So next question comes in from Extra Juicy. Thank you for your question. Question for David. Which came first, your degree or your young Earth belief?
Now that's a very important part of my biography. When I was in my first 2 years of college, I took the viewpoint that God simply used evolution to produce a pre-Adamic man and all the different creatures. And so those first 2 years, I had no real conflict in my thinking. During that time, I was part of the geology program at the University of Tennessee, Knoxville, while attending a junior college in Kentucky. And then when my wife and I married 50 years ago in 1972, we moved to Knoxville, and I got my undergraduate degree from the University of Tennessee. During the first few months of that experience, I retained my idea of a theistic evolution explanation and an old earth. In that time, I began to be alerted to the works of creation scientists like Dr. Henry Morris and others that argued for a young earth and that argued for an anti-evolutionary view. As the years went on, I had a chance to teach at Virginia State University near Richmond, Virginia. As a geologist, taught petroleum geology there. And the more that I saw of the data of the origin of crude oil and so forth, the more convinced I became that this had to be forming rapidly, that stratigraphic units had to form rapidly. And so by the time I had gone as a NSF graduate fellow to the University of Michigan in 1975, I was completely convinced of a young earth viewpoint. I was in the PhD program at Michigan. Looking back on it, I was a little bit too vocal, and they would not allow me to have a PhD as a young earth creationist.
Okay, David, thank you very much for that response. Next one comes in again, $5 super chat from Psycho Octopus the Thing. Question for David McQueen. Do you reason that the Bible is true first, then go about looking for evidence that confirms it, or vice versa?
Well, with 12 minutes left, I almost don't know how to answer that question. It is true that the Bible is not a physics textbook like Al is writing for his students there in the UK. So that is true. It's not a science textbook. But in those areas where the Bible comments about things, in my study, what the comment is true. For example, in Leviticus chapter 17 and verse 11, it says, "For the life of the flesh is in the blood." Well, this was written a long time before European scientists fully understood what the blood did and carrying oxygen and so forth, and certainly a long time before Greek and Roman scholars. So in those areas of science which touch, when I've read the Bible, I have seen that there's a correlation. That's the quickest answer I can give.
I appreciate you, the response there, David. So next one comes in from Hates Stairs, $10 super chat. And it's a hot one here, literally. David, please explain how you resolve the heat problem. So definitely a hot topic, and questions for you, David. Go ahead.
Figuring that Al would bring that up, I just happen to have my equations here. For those of you that may not be aware, Standing for Truth, George Bond and me have worked on this issue of the heat that's generated by catastrophic plate tectonics. And if you'll give me full screen so they can see this, here's the first counter argument. If you look at the calculus that's involved in the Carnot cycle, and I would imagine in this physics book that you're writing, Al, you got a section on this. Here is the differential of pressure versus temperature, dq over dt. The old Earth idea that all this is perpetually being drawn into the mantle and coming back up is actually a perpetual motion machine and violates the second law of thermodynamics. My argument is that in every closed system, entropy always increases. But this is actually my favorite argument. I better hold it up here. If you work on differential equations, and this comes from Stacy's book, page 203, the mantle creep gets really very interesting. I won't go through all this, but you can go to Stacy's book, which is out there, and note that this epsilon dot is the rate of deformation by creep alone. Well, if you know how differential equations work, they work backwards of everything else. And so at a very small difference, this mathematical evaluation of creep allows you to say, wait, this old Earth model is really insufficient and implies a catastrophic plate tectonic model. Yes, that's it.
Thank you, David. Catz, if there's anything you'd like to add or contribute to the heat question, go, or we can move on, whatever works for you.
Just very quickly, I'll just share my screen. As much as David just said then, he thought I was going to bring that up. I thought he was going to bring something else up. I thought he was going to bring helium diffusion rates up. I'm sure you're familiar with that argument. So I thought I'd look at helium diffusion rates, and I did, and I looked at the work from Humphreys, and I just happened to stumble across Humphrey. I can't remember. I don't know his first. What's his first name? Humphreys, the scientist.
Russell Humphreys.
That's him. I happened to come across a nice little quote of his in one of the papers he wrote that was dealing with the removal of heat from the Earth, and he wasn't as scientific as you was about it, David. He didn't have like the math, the maths around it. He just simply said, of course, God was directly involved, so it's possible that he employed some supernatural process which does not occur today and cannot be detected. So that was the answer that I thought you were going to give. So I was really impressed that you pulled some maths out there. I thought that's something I wasn't expecting.
Well, one of my goals, Al, is to impress you. So I'll save you to describe the Carnot cycle in class tomorrow.
Yeah, we'll do that off stream. Yeah, do that another time.
Debate mission accomplished. You've both impressed each other. So that's the goal, and we've met it. Okay, so next question comes in from, a comment from Heat Shield. Appreciate the support for Modern Day Debate and keeping these debates going. So Heat Shield says, thank you, Catz and Dave. Hope to see you both talk again soon. So, well, thank you. And yes, been a lot of good feedback to this professional and very technical discussion. I very much enjoyed it. Okay, so next one comes in from Good Question. And $10 super chat. Good Question is asking a good question. Question for David. David, do you believe there is a crystal dome that holds the stars, just like the Bible mentions?
Well, it turns out in a debate that I had 10 days ago with an individual who criticized my knowledge of Hebrew and wanted me to look at the cosmology that rabbis in 1000 AD or even 1000 BC. He challenged me to look at that's actually what Genesis is saying. I have looked at the Hebrew words. Now, I don't speak Hebrew, but I can read books and find out what it means. And he's simply wrong, but wrong in this way. I'm not saying that there are not some rabbis that viewed that idea of a crystal sphere, just like I'm not ignorant of the fact that there are some people, some of whom I have taught in my college teaching careers, that have tried to argue with me about a flat earth. And I will turn to them and say, how come the hull of a ship goes down first at the beach? So I'm aware that there are all kinds of people that have incorrect ideas, this idea is incorrect.
All right. Thank you very much, David. Okay, moving on to non-super chat questions. And so question comes in from Apologetics 101. Question is for David. Can you elaborate on the problems with the dynamo theory? And that looks like that's it. So
Okay.
Pertaining to the magnetic field decay, I think.
Yeah, let me get some of my my toys here. When I was at the University of Michigan, I was fortunate enough to take a geophysics class with a European scientist named Rob van der Voo. And Rob van der Voo was an expert on magnetic reversals. And he got me thinking all the way back in this would have been 77, 76, about the idea of the reversal of the Earth's magnetic field. A creationist before, let's say, 1980, thought that there was something screwy about the magnetic striping. And so what their viewpoint was, if you take the Earth and you look at the decay of the Earth's magnetic field, the dynamo theory is a theory in geophysics where this, I can put it back up here. I think I can. There we go. Their theory is that, sure, you can measure the decay, and sure, it's got a half-life of 1,400 years. But there is a process between the inner core, outer core mantle that regenerates the electric current. I think that that is an argument very similar to what Al has accused me of in the last 2 hours, of an argument wanting to prove your point without any really good seismic evidence. I think the evidence that we have is that there is an electric current flowing equatorially that by the right-hand rule of physics produces a magnetic field the way I've got my thumb pointed. Modern creationists see that there were opportunities during the time of the Great Flood, especially within the catastrophic plate tectonic model, that polarity would reverse. And so as lavas flowed out on the mid-Atlantic ridge like this, during the time of the separation of the Atlantic Ocean, it would get a different magnetic signature. I hope that helps in your thinking.
Well, David, thank you very much for that response. Kat, of course, you do have the opportunity to respond to anything unless you want to move on to the next question. Totally up to you. I think you might be on mute, Kat.
No worries. Sorry. No, I missed the question because I went for a wee. So, we'll move on. Yeah.
All right. No worries. Appreciate it. You guys have good endurance. So we're over 2 hours at this point. So next question comes in from Javardo. And it's a question for you, Kat. So we can't let David have all the fun here tonight.
No, finally, you get a question.
You've been on the hot seat, David. I appreciate you being a good sport. So this one's for Catz. Javardo, thanks for the question. Can you please provide some evidences that can be easily understood that points to the Earth being older than what Professor McQueen is claiming?
Yeah, sure, not a problem. I will just get something sorted here for you. So that can be easily understood. So obviously we're talking about dating mechanisms, aren't we? If we want something to be easily understood. So let's get this up for him. And when we say easily understood, I guess we'll see. Don't share the screen just yet. Sorry. In fact, you can. If I share my screen now, we'll do it without going into something I didn't get onto tonight, which might be something to talk about another time. David, is thermoluminescent dating.
Yes.
So you're familiar with that one, I'm sure you've heard of that. So here's a piece of pottery, and the thing about pottery is things like ceramics can be dated by something called thermoluminescent dating, and the idea is that when we get certain, I'm not going to go into too much because it's a quick question, but if we get certain crystalline structures that are underneath the ground, they're exposed to background radiation from underneath the ground. That background radiation can cause the excitation of electrons inside them. These electrons, as they get excited, are prevented from de-excitation because they get trapped in kind of like micro fractures inside materials. Correct me, David, if I get wrong in anywhere in this, okay? But they get kind of like trapped in certain imperfections in the material. Now, the thing about this is, when we take some of this stuff from underneath the ground and we put it above the ground, when sunlight shines on it, it gives these electrons energy, it liberates them, and then they remove themselves from these imperfections and they can fall back down to a normal energy level within the atom, right? Now, if I was to take something that had been under the ground and not exposed for light for a long time, I could liberate these electrons and measure the intensity of light that comes from them. I know you said in simple terms, but essentially, the more light we get from thermoluminescence, the longer something's been trapped underground. Now, that doesn't tell us that something is old. It tells us how long it's been in the absence of light. All right. So if anything, it underages things. And what we find when we go into Egypt, we find pottery that's 20,000 years old. We find, if we go to the pyramids, that the pottery we find in the pyramids is 6, 7, 8,000 years old for some of them, and that is so. This one was 4,300, but that is supported by other dating techniques that have got nothing to do with thermoluminescence. So, for example, the Khufu ships. I don't know if you're familiar with those. There was 2 of those found in the pyramids in Giza. And when the wood was tested with carbon dating, so not thermoluminescent dating, it backed up the date of the pottery. And when other structures in the pyramids were used, such as wooden tables and desks, and dendrochronology was used to date those, where we could see enough features, we found that they backed them up as well. So essentially, you go to Egypt, you go to the pyramids, and you find several different dating techniques, completely unrelated, all supporting each other, showing that each other is accurate, and just defies a young Earth completely.
Catz, I appreciate that thorough response. David, the floor is yours if you'd like to respond to any of it.
Yeah. Now, the Egyptology and the dating by thermoluminescence, I had to do some of this in my undergraduate days, so at least I know the technique. But the problem that we have is 2 different worldviews, if you will. As a young Earth creationist and as a catastrophic flood geologist, I've come to realize that no human structure could have survived the worldwide flood. So when I look at Machu Picchu, or I look at the pyramids of Egypt, I immediately say, oh, they were constructed after the time of Noah, contemporary maybe with the time of Abraham. And so for dates to be returned of those items, of 4,000 years, it doesn't exactly fit Bible archaeology, but there's a lot of things about carbon-14 that 21st century creationists have learned that allows us to maybe calibrate that. Thank you, sir.
Thank you, David. Catz, question was for you. You get the last word.
Yeah, okay, just very quickly. Okay, I understand that, if you say you see dates like that are contradicting your religious views, then you can't accept them. And I did open up in my debate. My opening statement in this debate with the quote from Creation Ministries, which said, "Science can't be the determinant of what we consider a plausible account." And I think you've highlighted that the science clearly shows it's older than the biblical take would have. And you are showing that you don't put science over over what the Bible says, and I suppose that's what it all comes down to.
Catz, thanks for that final word. And gentlemen, one final super chat came in, and then we're going to wrap it up as we are now slightly over time. I do want to thank David and Catz for the time that they've given to us for this epic exchange. I would say I've really, really enjoyed this. And so the final question comes in. It's a super chat, $2. Thank you so much. God Guy has a question for David. David, are dimensional aliens real / demons, or are they fake?
When I was at the University of Tennessee, one of the members of our Science in the Bible discussion group was a professor named Roger Rusk. Now, those of you that know American history may recall that there was a very senior member of the administration named Dean Rusk during that time. And so we were talking about the strange things you see at a Tennessee-Alabama football game and UFOs, that kind of thing. So I asked him if he'd ever asked his brother, who had access to secrets, what he thought about UFOs. And his only comment is, he said, well, brother, you would be amazed at the ultra secret military aircraft that we have. The point of view that I've come to over the years is most of what people see are just that, ultra secret military aircraft, lights in the sky. But some of the other occurrences probably are related to demonic activity. So it's a complicated issue.
David, I appreciate the response. Catz, is there anything you'd like to add?
Well, just quickly, I mean, hand on heart, I don't believe that, aliens have visited, or I don't believe in interdimensional beings or whatnot, but I will admit that is a belief. I don't rule out to absolute zero the possibility that aliens could have visited from other planets, and I don't rule out beyond possibility that there are beings somehow who've managed to come from another, because I know the laws of physics don't rule that out. So although I don't believe it in any way, shape, or form, I'd be a liar to say that it was impossible.
And Donnie, I want to make a final compliment to Al.
Sure.
Very much enjoyed this, my friend, and I hope in the summer we can find another topic that we can debate with this kind of vigor. I'll go back now to my friends. I want to take a 5-minute break, but I would like to come back and be part of that after show that you told me about. So
I'm so sorry, David. I'm afraid I'll have to cancel that show. Just let everybody know in the chat as well. I can't do it tonight. There's some family issues that came up. So
okay. Well, I understand family issues. In that case, I will move my cursor down and say good night to the three of you. We will talk more. Thank you, Al.
Thank you, David.
David, thanks for the final word, and I'll wrap things up. That concludes the Q&A. And great questions, excellent questions from the audience. This really was a fantastic debate. I've enjoyed it. Catz, well, actually, Kaz, I'll hand it down to over to you if you wanted to kind of wind things down and wrap it up.
That man's got to go back to the bat cave. Bye-bye.
Bye,
See you later, David. Thank you. Yeah, no, I just want to say thanks. Sorry.
No,
yeah,
sorry,
really enjoyed that. Really, really enjoyed that. Thank you so much. And I'd love to come back on. Well, that's it. Yeah, happy to touch base with you again, Donnie, and more than happy to do any debate that you're or James. I don't want anyone taking away that I've got to get you, but it's nice to touch base with you again. So anytime you're moderating, or James as well, to be clear, I'm happy to step in.
Well, it's great to touch base with you as well, Catz. Always a pleasure. I'll definitely stay in touch, and we will hopefully set up some fun shows, some debates in the future. So, Catz, thanks for doing this. You are in the future. It's late for you, so we'll let you get out of here and get some sleep. Thanks for a great debate, Catz.
Thank you. I'll pop off then. Thank you. Bye-bye.
All right. Well, Donnie, you want to say anything to say goodbye to everybody real quick?
Sure. Yeah. I want to thank everybody for tuning in. I appreciate all the support that has come in for James Coons and all the work that he is doing here on Modern Day Debate, putting on some really excellent and important debates. So as always, time has flown by. I am kind of a debate addict. And so these debates do fly by. 2.5 hours. I think it was a thorough debate on scientific evidence of a young Earth. Critical thinking is important, guys. That's why James, that's why myself over at my channel, this is why we host so many debates on these kinds of topics. So please share around this content, share it around to your friends and family. If you're not yet subscribed, hit that subscribe button. So Kaz, over to you.
All right. Thank you so much, Donnie. I really appreciate it. And you've done a great job tonight. Really, it's a very admirable job you did tonight. Thank you so much. I just want to say, once again, thank you to you. Thank you to the debaters who are the lifeblood of the show. Thank you both, David McQueen and Catz, for showing up today. Thank you to the moderators in the chat for elevating the conversation. Thank you to James for creating this platform, and everybody in the audience who sent in super chats, and everybody who commented and elevated the conversation as well. Thank you to everybody else. And like it if you loved it, share it if you want to spread it, and subscribe. We have many more debates coming your way that you don't want to miss. Our speakers are linked to the description below, so check them out. Do it right now. Everybody have a great night, and remember, keep sifting out the reasonable from the unreasonable. Have a great night.